let's get started. So what we want to do is build a list of steps for making an API. I'm splitting this into two sections. We're going to have setting up the server and adding a route. And I'm going to just set this all to the camera. Cool. So let's talk about what's involved with setting up the server. What are the things that we have to do? This is the very first thing that I did.
Created app.js.
Before that even. npm init. So npm init. Cool. Then what did I do?
npm install.
Yep. So let's talk about the things that we installed. What were they?
Cores, Morgan, NodeMon, body parser, .env.
Cores, Morgan, NodeMon, .env. I'm missing a real important one. Express. What else? How do we read data?
Connect.
Body parser is what I was looking for. Connects. Database driver?
PG. Or
PG. Yeah.
So all of these will fall under middleware?
It's just fun to hear you talk like this. Not all of them. Cores is, Morgan is, body parser is. Those are the middleware. All of them are packages. Only those ones are middleware. All right, so I installed those things. Then what do I do?
You go from your package.json and edit the scripts.
So I'm going to do that next. What do I need to do before that?
Is this where you create app.js or app.js?
I love it.
So are you literally, at this point, you just have like an empty directory and you're installing all this shit?
Yep.
And then you're going to make your app.js?
Yes. So we're going to make an app.js and an index.js.
Terminal talk, we call that touching.
In terminal talk. So make an app.js and an index.js. And I'm going to say write the listener on index. And then write the app config on app.js. And then, Clark, what happens?
Then you edit package.json.
Yep. Add start scripts. To package.json. Cool. Then what do I do?
This connects to it.
Yeah, I'll take that. We'll say connects init. That gives us the connects file. What do we do then? How do I make a database? Yeah, like that. So we create DB, whatever your database is named. Next thing I would do is save the name of that database where? Yep.
Just like a comment or something?
Save the name of it.
Right, like that's not like any functional script, just like comment, like make a comment saying like my database is called
Nope.
whatever.
Looks like this. When I look at my .env, that local database name, that's what I want. And the way that that gets referenced is like that. That is pretty cool. All right, so I save the name in .env. Then what do I do?
You set up your next file?
Yeah. Let's say add the development object to the connects file and load your .env. I'd also say this is probably a good time to git ignore. We might even do that earlier in here. We'll say git ignore what two things? .env and node modules. Okay, so now what?
Do you need to require .env on all your JS files?
No, you only need to use it in places where you're going to be using process.env and using those variables. And strictly speaking, it only needs to run once. So if you put it like, on your index.js or something like that, it would theoretically be available anywhere. The problem is things like your migrations and seeds, they use this connects file, but they don't actually have anything to do with your app. So it won't run there. There's no problem with like using it too many times, but that's the thought process there.
I know I did this, but just to make sure.
Mm-hmm.
Setting up a global gig or
Yes. But like I still think it's nice to put it in the project, because when I fork and clone your repo and I bring my shit down, I don't want to accidentally commit my node modules if I don't have a global git ignore for that. Mm-hmm. So let's take a look through our files. So migrations are all route specific. So our models, so our routes, so our seeds. Let's take a look through the rest of this. What else do I want to do on my, I say write the app config on app.js. So yeah, that's the middleware. We've done that. I'd probably put this stuff around that time also. What am I doing there?
Error messages.
Yep. So like add 404 and 500s handlers. Cool. So am I missing anything else? I think that's pretty much all of our server setup. You might want to add the deployment steps in here also. So what do we have to do to get ready to deploy? Actually, hang on. Before we do that, one thing that we missed. What's this file? Okay. We're going to add a database connection. All right, and then we deploy. So what do we do? First step? Heroku apps create, or do it on the GUI or whatever, but make a new Heroku project. Then we're going to add the URL and push. Then what? You've pushed it up, then yep. Once it's up there, and like we found this out on Monday, it won't let you add a database or add a dyno or anything like that until it has something. It needs to know what kind of project it is, that sort of stuff. So once you've done that, you can add a Postgres database. Then what?
Now, can I ask a question? I know I can just Google this since we're talking about it.
Yeah.
What is a dyno? That's a
Ooh.
D-Y-N-O?
D-Y-N-O.
Okay.
A dyno is not like a computer science thing. It is a specific Heroku idea to help with understanding the billing. So what a dyno lets you do, it processes one simultaneous request. So if I have you request something from my API and it takes 2 seconds for it to process, while if that's going on, if somebody else requests, they have to wait in line. So imagine at some point the line gets longer and longer. You have 2 dynos, you can handle more than one. You can handle 2 requests at the same time, and 3, and then 4. So dyno is their word for that, and each dyno costs $7, I think. Cool. So I've added the Postgres database to Heroku. Now what do I do?
Run migration.
That's all like route specific stuff, but good call. I have that URL that it makes. I need to do something with it. What was it?
Oh, you make your production route. Or
Before I do that even, yep, I need to add the database URL to the .env. Then what do I do?
That's when you do production.
Yep. We're going to add production to the connects file. And then, last step. Slide, push it. Yep, I gotta push up to Heroku. Cool, and now I have a server running in the cloud. Now what we specifically didn't do is build out any of the routes. So let's talk through that process. Assuming that I have a working configured server, what do I need to do to add a route? Step 1.
Is this what you do with your queries?
That's probably a little bit further down. Step 1.
Is this to create your migration?
I would even do this before that. Yeah, well, even before you get to the router, just add the route.
What exactly is the route?
Sure. So what the route does is it matches 2 things. It matches an HTTP method and it matches a URL. So if you, remember this is mounted on /animals. If you do a GET request to /animals, that means that this route matches and this function will run. If you do a GET request to animals /anything, then that matches this. This function runs, and whatever that anything is available on request params ID. It's just pattern matching. Looks for the very first thing that matches and runs that. Cool. Just like in Vue. Works the exact same way. So, yeah, so first step, make the route. The thing that's going to match. And what I would do, hard code the response. There's a specific reason I recommend doing that. If you hard code the response with just arrays and objects and that kind of stuff, now it's working. It's much easier to keep something working as you add complexity than it is to get it all right the first time. So this is going to end up going back through that model, which is going to go through the database and all that kind of shit. That's a lot of places something could break. If it's working here and then I add one step and it breaks, I know exactly where it broke. So that's why I recommend being very slow and methodical about that. You saw, like, I've done this hundreds of times, still made plenty of typos and mistakes. Just happens. All right, so make the route, hard code the response. What's the next step? I would do that like pretty much all through. This is assuming that you're testing pretty much the whole time. So I've hard coded it now. Add a model. So in some of the exercises and stuff, I just had you guys put all these things in a queries file. In real life, you want to kind of group those together with all the different, types of things that you're dealing with. So, all right, so I have make a model, if it doesn't exist already, and then add the command to the model. List, read, write, whatever. Add the command to the model with hard-coded data. Now we're taking that hard-coded data that we had in our route, and we're just moving it back. So now from the, I don't know if you guys noticed this, but in this route, once I had this going with the hard-coded data, I never touched it again. It doesn't know if like animals.list is returning static data or database shit. Doesn't care. It just knows it's asynchronous. And so if you can prove that that works, you don't have to debug that anymore. Cool. So I've added the let's say method. Okay, so we add the method to the model. What do we do now?
Where does the schema fall into?
Ooh, it is the very next thing that we do. How do we manage the schema on a database? It connects. Migrate. So we add a migration.
Is it just like running your thing, like after you push it to a run?
No, this is, all right, my server's set up, but it doesn't do anything. Now I want to list animals. So this is that step of that, the process you'd go through. All right, so we'll add a migration, fill all that out, and then run, let's say run locally and in production. You have two databases, the one on your laptop and the one that's on a server in Oregon somewhere. Okay, so we add a migration, we run it locally in production. Then what? Add a seed. Test data. We're going to run that locally and in production. Then what? So now we have a database with the schema and some test data. We have the route set up. We have the model set up. What do we need to do? Nope, we did that here. Add a seed, ran it locally and in production. We need to take this method we added to the model and make it use the database. So we're going to change method to use the database connection. Yeah, I think that's all of it. Let me, well, then deploy it. So let's take a look. Yep, that's all that stuff. We have the migrations and seeds. We have the model. We have the routes, seeds. Everything in app is taken care of. Database connection, index, connects file. There we go. Then rinse and repeat this for as many routes as you want to add. Ta-da! That is backend development. So one thing I don't have on here is I don't have anything about testing, like automated testing. I'll show you how to do this in a second. But that's another thing that you could do once your server is set up. Before you do any of this shit, write a test for what winning looks like. And then instead of checking all this stuff manually, you can just go test, and it'll bark at you as soon as you break something.
So if somebody paid $30 an hour just like do this all day?
A lot more than that.
Really?
Yep.
But is it literally like just this, or is this like?
Well, like, so that's a great question.
Like, is this like my first backend by Fisher Price, or is this like the real deal?
It depends. So I write stuff just like that. Like, the organization is a little bit more complicated, but here's your LMS's backend. So if I go to tier, all right, so this has an index.js. It's a little bit more complicated, but it's really just because this process.env.port, I want to be able to store that somewhere so that I can, echo it back. Same thing with all of these. The errors are a little bit more verbose, but otherwise it's still just error listening. And then my app.js here, like.
So were those backend functions like functions the way we think of like, oh, like
Mhm.
something that does
Yep.
like, puts all the letters to lowercase, or is that kind of just like were you just kind of like assigning things in functions? Were they like problem solving functions or more like declaratory, if that makes sense?
Porque no los dos, both. So yeah, here I am setting up some middleware. I use one of these like pretentious applicative for each loops for like setting up these routes, but same kind of idea. I'm just looping through all of these words, looking for the routes folder in there, and mounting the routes. Hey, a 404 handler. Hey, a 500 handler. Same shit. My utilities, these are like pure functions, helps you get the date or helps you base 64 encode something. And my routes, hey, what do you know? These are the same shit that we did before. The only difference is that instead of writing the function in line, I have it in another file. But like these should look vaguely familiar. Like request, response, pulls in a model, calls something on it, and then returns the response. Works the same way. This one in particular is kind of neat because this is Slackbot. So this just uses the Slack API, takes my token, gets your name and your username, and
Did you invent that, or you just like copy that from their docs?
I just use it from the docs. I use the exact same process that you guys do in like the stripe drills. Follow the instructions, copy and paste, change shit until it works. So the models for those are, again, a little bit more involved, but not that much. So like the help queue. Adding rows, updating rows. I think this has the actual connects queries in it. Oh, right, because this doesn't have a database. This is all spreadsheet based. So I guess that's the other weird thing about it, is instead of using a Postgres database, I wrote this library that uses a spreadsheet as a database. Makes it easier to update. It's also why the LMS is slow as shit and takes like 7 seconds to load every time. But remember, the first version of Tier, when G70 started, was literally a static HTML page that I made. So I've just built this back as we've gone. So anyway, like, this stuff looks a little bit more fancy and is more robust and has all this sort of shit, but fundamentally, it's still just that. Cool. So here's our steps for adding a route, and then step 0, I would say write test. Some other things that we're explicitly not covering here, but are a part of backend development. Authentication. It's kind of complicated, but similar thing. Just find a tutorial, follow the instructions, make it work for your app. That's what we all do. And the other thing that like is a regular part of a backend developer's life is optimization. So a lot of this stuff very dependent on how fast you can run it, and because like these are commodity servers. That Heroku shit where you have to like pull open the slider to be able to handle more simultaneous requests, like that costs money. If you can run the stuff faster, you don't need as much concurrent shit. So that's where like this computer science and optimization, a lot of that stuff comes in, is just making that stuff run as efficiently as possible. And so instead of doing 3 different queries to your database and then mashing the shit together in JavaScript, the most expensive thing you can do is a network request. And making a request to a database is a network request. So you try to write a gnarly-ass query that gives you back all of the data, and then you reformat it. It's a faster way to do that than 3 different queries. Shit like that is part of a backend developer's life.
I missed the first one.
Yeah.
For optimization.
Yeah.
The deeper dives.
Optimization and authentication. Yeah. So can anybody in the public read the animals? Can anybody add one? So then you start getting into, all right, have I given you a token that says you're allowed to do this?
And that's where I go login.
Exactly. So now I know who you are, but what are you allowed to do? So that's called authorization. Authentication is who you are. Authorization is what are you allowed to do. So you have to manage all of that kind of stuff.
You've got like user versus admin tokens,
Mm-hmm.
stuff like that.
Exactly.
Like a user who's
Mm-hmm.
admin to do all of that.
Exactly. And you might have a bunch of different levels of that. You might have a student, a teacher, an administrator, 20 different levels of permissions. So that stuff is not a part of this. And if you leave the program not knowing how to do any of that shit, you'll be okay. But that is also a part of backend development. Cool. Questions about this so far? Sweet. So one more thing I want to do. I do want to show you what writing a test looks like. This you might just take to this and you're like, oh shit, why haven't you been telling us how to do that this whole time? It is relatively easy. So if I install, all right, Mocha and Supertest are in there. So I'm going to make a folder called tests, and I'm going to make a file called animals.js. Cool. So if I go to that test file that I made, I'm going to pull in assert, which is built into Node. And I'm going to pull in, let's see, I always have to look at the docs for it. All right, and I'm going to call this request, require in supertest. And I'm going to pull in the app. This is where having that separated app from the index is really nice. So we'll say, all right, require in the app. And now this works a lot like Cypress because Cypress uses Mocha under the hood, so this should be kind of familiar. I could say animals, routes. And inside of that, I'm going to have what kind of block? It. Just like Cypress. So I might have one for it can list animals. And then what you do is you use request, which remember is just the supertest thing we pulled in. We're going to pass app into it. And then we can say, hey, I want to get /animals. You can set headers. You can set a body if you want to test a post request or something. And then you can actually do this a couple ways. You can say like expect 200. There we go. Say, hey, I'm expecting a 200 response from that. And then you can do a .end function, or .end call. And that will take error and response. And you can say something like if error return done with error. Where did done come from? Oops, there we go. In these tests, if part of your test is asynchronous, you just pass done into the it block, and whenever you call that, it finishes the test for you. And then I might say, oh sweet, actually hang on, I like this a lot better. Let's use promises for it. .then, and we'll .then the response. And we'll catch the error and say done error. And over here, we'll say assert.equal response.body.animals, and then whatever you were expecting to come back from that. So in our case, be something like this. I can grab all that from the seeds. That's the thing that should be coming back. All right. And then I'll call done. All right, let's see if it worked. If I go Mocha tests animal.js, it breaks because I put a space in the wrong place. Cool. That's what I actually got back. Did not have an expectation in there. Weird. Oop, assert.d equal. Because it's an object. There we go. Cool, it's passing now. So if I, just to prove that it's not smoke and mirrors, if I get the name wrong, it should fail it. Yeah, there we go. So you can do this as a step 0. You're saying, hey, I know I'm done once this works. But what's neat is once you've hard-coded the response, the test passes. Now all you need to do is keep the test passing. And as your app gets more complicated and you're adding a bunch of shit, you can run those tests at any time. It'll just tell you whether or not you broke anything. And so you don't have to like close your eyes and hope that like when you push to Heroku, it didn't screw up your entire app. And then you can do something like over in package.json, you can say test. My test command is mocha tests animals.js. And now it's just npm test. Ta-da! Sweet. Other questions?
I have some questions.
Okay.
That's kind of like off the mark a little bit, but
Okay.
super tests. What layer would that fall in as far as the pyramid?
What a great question. I would put supertest pretty damn near the top. It actually functions a lot like Cypress, but what's cool about it is that it doesn't have to like fire up a browser or anything, so it runs fast as shit. But it serves a very similar function to Cypress, but only works on Express apps. Whereas like Cypress doesn't care what your app is, as long as you can hit it with a browser. You can technically test backends with that also, but then you're firing up a browser and making a request and waiting for it to come back. It's just too slow. The only thing that I would say is like higher level for an API test than this would be you can write these tests with Postman also. And Postman is just a browser. It's also fairly fast. But then you're really hitting an endpoint with a browser and seeing what comes back, because this is dependent on supertest working exactly like whatever browser is being used works, which is a big assumption. Cool. Other questions?
So, like being exposed to like the end-to-end testing tools, is still better, I guess, more functional to do unit tests with Mocha.
So I'll give you a good example of like what something that would be a good unit test would be, because like this is not a unit test. It uses Mocha. It could use Chai. If I just change that to that, now I'm using Chai as assert instead of the built-in one. I don't see it. You can get an awful long way with just assert. So I use the built-in one mostly. But just because this is Mocha Chai doesn't mean it's a unit test. It's really testing the system, so I'd put that pretty high up. A thing that you would unit test on the back end, any kind of like utility sort of thing. So in the app that I was showing you, the LMS back end, there's something I have to do where I have to decode a base64 image or something like that. I get a big long ass string and I need to do a decoding on it. That's a unit test. It's like, cool, if I give you this string, can I get this result out? We actually take a look at the code for that. So those kinds of tests would be like, perfect. So looks very similar, but I pull in the little function that I wrote to decode these things, and I assert that if I call that with this string, it should turn it into that string. That's a unit test. Or this date one that I have. Oh, I haven't written the test for that yet. But yeah, a little bit different. What else? Cool. So let's do this. Let's break for lunch, and when we get back at 1, let's see if we can follow our own instructions here and build a server. Sound good? Sweet.
I have a quick second question.
Okay.
About Tom's question.
Okay.
So like